Hello friends, today's subject Basic Electronics Engineering. Myself D.N. Mehta, Assistant Professor, RMT Sinhagad School of Engineering, Varje, Pune. Today we are going to deal with unit number 3. Unit number 3, which is called as Number System and Logic Gates. The content of the unit number 3. This is the content of unit number 3. We are dividing our complete unit in 3 parts, that is number system, basic gates and introduction to microprocessor and microcontroller. Today we are going to learn about basic gates. Very simple kind of topic. So before going to learn with the basic gates, we have to understand what are the digital signals. What are digital signals? A digital signal, according to positive logic, have 2 basic states. A state 1 can be a logic 1 and a state 2 can be logic 0. Logic 1 can also be called as high logic, that can be represented as H, and logic 0 can be represented as low, that can be shown as L. Other form of notation for logic 1 and logic 0 are: for logic 1 we can say that it is an on state, for logic off we can say that it is off state, and for either it is +5 volt and either it is on volt. Basically these two logic are called as a binary format. So binary have always a 2 states, please remember. Now we are going to start with the logic gates. So what are logic gates? So in a very simple way, logic gates are used for digital signals. Logic gates have basically n inputs and only one output. Please remember, logic gate has n input and one output. N input, any integer value, and it has only one output. Now, there are three types of digital gates. They are called as basic gates, universal gates, and derived gates. You can see over. This is basic gates, universal gates, and derived gates. So what are the types of basic gates? We have AND gates, we have OR gate, we have NOT gate. So AND gate, OR gate, NOT gate are called as a basic gates. Universal gates, NAND and NOR are called as a universal gate. What are derived gates? XOR gate and XNOR gate. Here X stand for exclusively OR gate. So as you are seeing it, this is consist of OR gate with exclusively. So it is a derived from OR gate. We are going to see it in further slides also individually. Now NAND and NOR are specifically called as a universal gate. So this is very important. Please remember right now, NAND and NOR gate are called as a universal gate. Also NAND and NOR gate are called as derived gates. They are basically derived gates because they are derived from basic gates, but moreover they are called as universal gate. So what are NAND and NOR? They are universal gates, please remember. And yes, so basic gates, universal gate, derived gates. Basic gates are of 3 types: AND gate, OR gate, NOT gate. Universal gates, NAND and NOR gate. Derived gates, exclusively OR and exclusively NOR, XOR and XNOR, correct, please remember. So total in all we have the 7 types of gates. They are AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate and XNOR gate. I think very much clear. Let's see one by one what is AND gate. General form of AND gate is called IC7408. IC7408 is the AND gate. As I already told you, this all logic gates are used for the digital signals. These are digital gates. These are also called as a digital gates. So we can have the n number of input. Here n can be any integer value. For right now we are considering a 2 input for our easy understanding. So for 2 input and 1 output, our NAND gate can be shown like this symbol. This is a symbol for NAND gate. Please see symbol. This is symbol for NAND gate. We have the 2 inputs. This is first input, this is second input. First input, second input, and this is 1 output. Here input can be any number. For our simplicity, we are using 2 input. Here input can be n number. If I say 3 input 1 output, yes, we have 3 inputs here. If I say 4 input, yes, we can have a 4 input also. For our understanding, we are using only 2 input 1 output. Simple understanding. So this is input side and this is output side. As per seen by the logic symbol, this is symbol for AND gate. We can see that here we have 2 inputs. This is first input, second input and 1 output. If I name this first input as A and second input as B, so this is my first input A and this is my second input B, and if I name my output as Y. So let's consider my inputs are A and B and my output is Y. So since input are of 2-bit, so that 2-bit can be, as I already told you, for a digital signal we can have the input either logic 1 or logic 0. So for a 2-bit input we can have a 4 number of combinations. What are that combinations? We can have 0 0, we can have 0 1, we can have 1 0 and we can have 1 1. So this is a combination. For 2 input we can have 4 combination. For 3 inputs we can have 8 combination. So this is related. And since this is digital, so always here input and output will be in the form of digital only, that is in the form of binary, either 1 or either 0. So for input 0 0 0, the output Y is 0. For input 0 0 1, the output Y is 0. For input 1 0, output Y is 0. For input 1 1, output Y is 1. So what NAND gate output table state that the output is high if and only if all the inputs are high. So you can see here from here, the output is high if and only if all the inputs are high. If my both the inputs are high, if my all the inputs at the input side are high, then only my output is high. High means 1, low means 0. So if my input is high, all the inputs are high, then output is low. See here, if any of the input is low, then output becomes low. If any of the input is low, then the output is low. Yes, clear, very much clear. AND gate. AND gate means AND operation. It is a AND operation. Generally, AND operation is shown by the multiplication. You can also see that 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, and 1 into 1 is 1. So AND operator can also be called as a multiplication operator. Yes. So what you have to remember, the output is high if and only if all inputs are high. So you can state here. So this is called as a symbol diagram for 2 input 1 output, and this is called as a truth table. This is a truth table where we can have the input combinations and we can have the output combinations. Input combinations are A and B, output combinations are Y. Since we have 2 input, so 2 input combination A and B and 1 output only. All logic gate has only 1 output, please remember this. So 3 things we have to remember here. What is the thing? First thing, we have to remember the IC number. What is the IC number? IC7408. IC number is IC7408, correct? Next is, it has a 2 input, they are named as A and B, and 1 output Y. Here input can be any number, but for our simplicity we are learning as for a 2 input. So A and B are the input and Y is the output. So this is a symbol for AND gate. Please remember the symbol. You can practice this symbol, very simple symbol. Sometimes in paper they can ask for 1 mark for the symbol drawing. So you can practice this symbol. Yes, very simple symbol. And this is called as a truth table. Truth table, yes, input output combination. What is truth table? Input output combination or input output relation. It gives the input output relation. So we have 2 input A, B. So they can have the 4 combinations 0 0, 0 1, 1 0, 1 1. So I have already stated you, output is high if and only if all inputs are high. So for when both the inputs are high, output is high. When all the inputs, any of the input is low, see here both the inputs are low, here only one input is low, here only one input is low. If any of the input is low, then the output is low. Are you getting? Yes. So this is for the 2 input. Now let's consider the case for the 3 input. Say for example, right now I am not showing the here the truth table, but let's assume that we have the 3 inputs A, B and C. Now if all the 3 inputs are 1, that is 1 1 1, then only the output will be 1. If the input combinations are 1 0 0, then output will be 0. Why? Because if any of the input becomes 0, output becomes 0. The output is high if and only if all the inputs are high. You have to analyze like this. Yes, Is it clear? Yes, very simple. Let's go for the next gate, OR gate. OR gate IC number is IC 7432. For our simplicity, again we are taking 2 input, 1 output. This is a symbol for OR gate. Please see that this is symbol difference for the OR gate and the AND gate. Please remember, this is a symbol difference for OR gate and AND gate. Yes, you have to practice the symbol. Symbols are asked for the 1 mark. You can draw the basic symbol, that is for 2 input and 1 output. Now here the truth table. What is the truth table? Input output relations. 2 input means A and B are the 2 input and output is Y. Here output is Y. So what the statement says? The output is high if either or all the inputs are high. If all the inputs are high, then my output is high. If all the inputs are low, then my output is low. See here, for AND gate, if all inputs are high, then output is high. For OR gate, if all the inputs are low, then output is low. See, if both the inputs are low, then output is low. If any of the inputs are high, then the output is high. Then the output is high. Correct? Getting? Yes, very simple. Please draw the symbol, practice the symbol. You have to practice the symbol because symbol diagram is very much necessary. You have to draw the symbol for AND gate, OR gate. See the difference in the symbol? Yes, we are understanding it very different. Yes, this is a truth table. See, if both the inputs are high, output is high. If both the inputs are low, output is low. Otherwise, it is high. Easy? Truth table is easy? Yes, correct. Let's take the example for 3 input. If we take for the 3 inputs, then how will be my output? Let's say if my 3 inputs are A, B and C, if all the 3 inputs are 0, 0, 0, then output is 0. Second combination, if my input is 0, 1, 0, if any of the input is 1, then output is 1. Correct? For OR gate. Please understand. Please understand. Yes, very simple. Let's go for the third gate, NOT gate. This is the third type of basic gate, IC 7404. IC 7404. Practically, we are using this IC. IC stand for integrated circuits. 7404 stand for NOT gate. Now, what is NOT gate? NOT gate are also called as inverter. Please remember, NOT gate are also called as inverter. Now, basically, IC 7404 is also called as an hex inverter. We are going to see the IC configuration of this IC also. I will going to show you the IC combination also. So, IC 7404 is called as an hex inverter. Now, please remember, earlier AND gate and OR gate, we have seen that we have n number of input and 1 output. Yes, and basically all gates have minimum 2 inputs. All gates have minimum 2 input and 1 output except NOT gate. A NOT gate is a kind of digital gates or logic gate which can have only 1 input and 1 output. Please remember the key point. What is the key point? A NOT gate can have only 1 input and 1 output, whereas all other logic gates has minimum 2 input and only 1 output. I said minimum 2 input and only 1 output. Only 1 output. But only NOT gate is an exception. A NOT gate have only 1 input and 1 output. 1 input and 1 output. So you can see the symbol of NOT gate. A NOT gate inverter, also called as inverter. This is a symbol of NOT gate. This bubble indicates the NOT gate. So you have to draw this type of symbol and you have to insert a bubble. Mark the bubble over it. So bubble indicates the NOT gate. So please remember, it has 1 input and 1 output. Now, what according to truth table? As I already told you, it is called as an inverter. And since we have only 1 input here, so if I say that we have input as 1, so it can be either logic 0 or logic 1. So if my input is logic 0, then output is 1. If my input is logic 1, then output is logic 0. This is only called as an inversion process. Inversion. For logic 0, I am getting 1 output. For logic 1, I am getting 0 output. That's why NOT gate is called as an inverter. Inversion output. This is an inversion process. It gives for logic 1, logic 0 output. For logic 0, logic 1 output. Very simple. So please remember, NOT gate IC number IC 7404. This is a symbol for NOT gate. Please mark the bubble. 1 input, 1 output. Inversion. It gives the inversion output. Inverted output. Inverted output means opposite output. Opposite. It will produce the opposite form of the output. Yes, simple, very simple. Let's see the next, that is a universal gate. Yes, these are the three kind of basic gates earlier we have seen: AND gate, OR gate, NOT gate. Now we are going to see universal gate. Universal gates are NAND and NOR gate. Yes, remember the earlier slides? Yes, NAND and NOR gate, they are called universal gate. So what is the NAND gate IC number? IC7400. IC7400 is the NAND gate. Now what is NAND? I have told you it is called as a universal gate, but it is also called as a derived gate. Why they are called derived? Because they are derived from the basic gates. What are basic gates? AND or NOT. AND gate, OR gate, NOT gate. These are the basic gates. So this NAND gate is derived from the two basic gate, that is NOT and AND. It is a combination of NOT and AND. See here, AND stand for NOT, and this is a AND. This is a AND, correct? So this is nothing but NOT plus AND, combination of NOT plus AND. So we have the AND symbol, and we have marked the bubble over it. So this bubble indicates the NOT. And we have the AND symbol. So this becomes the symbol for NAND gate. So we have AND gate symbol and the bubble mark over it. So that becomes the symbol for NAND gate. Now what is NAND gate? NAND gate truth table output is completely reverse for reverse like a AND gate. So for an AND gate, you remember that for if both the inputs are high, then only we are getting output as high. So, and if any of the input is low, then the output is low. So totally reverse of it. I told you for the inverter it reverse. So here if both the inputs are high, then we are getting output as 0. Reverse of AND. Inverse of AND, correct. So for 1 1 we are getting 0, and for other we are getting 1. Here A and B are the two inputs and Y is the output. We are going to say for the simplicity, for 2 input and 1 output. A and B is the input, Y is the output. We can have more number of input also, n number of input. Only NOT gate is an exception, where we can have only 1 input, whereas all logic gates, digital gates have minimum 2 input, and the input can go up to n number, but the output is only 1. Now next universal gate is called as a NOR gate. So what is NOR gate? IC7402. As like a NAND gate is a combination of NOT plus AND, NOR gate is a combination of NOT plus OR. Very simple to understand now for you. Very simple. Huh? So this is a symbol for NOR. See, OR gate plus bubble. So what bubble indicates? It indicates the NOT gate. So this is called a symbol for NOR gate. So now you can answer the truth table also. So as per OR gate, what we have for if the inputs is low, then the output is low, otherwise output is high. So here NOR gate means inversion of OR gate. So if both the inputs are low, then the output is high, otherwise the output is low. See, the output is high when all the inputs are low. When all the inputs are low, output is high. This is inverse case of OR gate. Clear? Very clear, much clear. You can what you can do, we can form one common table where you can have A and B as an input, and you can have multiple output in the same table. I will give it to you. Now next, derived gates. These are the derived gates. That is called as an XOR gate. XOR gate IC number 7486. Practically we are using this IC, though this is IC number is required there. What does XOR stand for? It is exclusive OR. So this is basically OR gate, but it is exclusively OR gates. In some book we can write as XOR also, and we can write EXOR also. Since it is EXOR, so I think it is more correct. It is EXOR only. You don't have to use shortcut XOR only. You use complete EXOR, exclusively OR, where EX stand for exclusive OR. So please look the symbol. What are the kind of symbol? What is the symbol type? See, this is a symbol for XOR gate. Simply you have to draw the symbol of OR gate, and then you have to mark this design, this pattern, one more line. So this becomes the XOR gate. Now why like this? Because this is an exclusive OR. Now likewise, logic gate, it can have multiple inputs and only one output, but for our easy understanding we are considering 2 inputs as A and B and one output Y. Now what the truth table says, please, A and B are the input and Y is the output. I already told what is truth table. It is a combination. It gives the relation between input and output, input output relations table. So A is input, B is input, Y is output. Since we have two inputs, so we have four combinations: 0 0 0 1 1 0 1 1. So what the statement says, the output is high when the inputs are not same. The output is high when the input are not same, or when odd number of inputs are 1. So output is high when the input are not same. So for 0 0 output will be 0. For 0 1 output will be 1. For 1 0 output will be 1. For 1 1 output is 0. When odd number of inputs, then output is 1, high. So when odd number of inputs, see here we have the odd number of inputs. Odd number of input is high, odd number of input is high, then the output is 1. Or the output is high when inputs are not same. Here the inputs are same. Here inputs are same, so output is low. Here inputs are not same, so output is high. Not same, 0 1 not same, output is high. Yes. So this first statement can be used for two input, whereas this further statement can be used for multiple inputs. That is, when odd number of inputs are 1, then output is high. So you can see here 1 1. So this is a even number of input. So here 1 1 are even, so that's why output is low. Here 1 is odd. Here 1 is odd. Out of 2, 1 is odd input. So output is high. Yes. So say for example, if I give you the case for 3 input, see A, B, C are the 3 input and Y is the output. So for 3 input, we can take the case as 1 1 0. Yes, for 1 1 0, if I take 1 1 0, then for 1 1 0, what should be the output? What should be the output for 1 1 0? Now here you can say that for 1 1 0, how many number of ones are there? There are even number of ones. Since we have even number of ones, so output is 0. Yes, whereas let's take the case as 1 1 1. If we have the case 1 1 1, then 1 for 1 1. For 1 1 1, we have the odd number of ones, then the output is 1. Correct. Let's go for the next. XNOR gate. Now this is a derived gate which consists of XOR plus NOT. So this is exclusively NOR. Also you can say the exclusively NOR. So we can have NOR gate and you can mark this is exclusive mark. IC number is IC 74286. Now totally this is a inverse of XOR gate, you can also say, or you can say that it is exclusively NOR, or you can say that it is XOR plus NOT, also you can say that. So this is XOR and this is a NOT gate, or you can say that this is exclusively NOR. Either way you can learn it. So this is a symbol for XNOR gate, XNOR, exclusively NOR. So output is high when the inputs are same. So output is high when the inputs are same. See, now you can understand, for as the NOT gate comes, when the NOT gate comes, what it makes the output as inverted. It makes the output as inverted. आउटपुट को रिवर्स इन्वर्ट बना देता है. अगर इनपुट 1 है तो आउटपुट रिवर्स हो जाएगा, इन्वर्ट हो जाएगा. सो जो आपका एक्सऑर का ट्रूथ टेबल था वो यहाँ पे आपका इन्वर्ट हो जाएगा. तो एक्सऑर को आप इन्वर्ट करेंगे तो आपको एक्सनॉर का ट्रूथ टेबल मिलेगा. और यू कैन कीप रिमेंबर दिस ऑल्सो. द आउटपुट इज हाई व्हेन द इनपुट्स आर सेम. When the inputs are same, the output is high. Inputs are same, output is high. Inputs are differ, the output is differ. Output is low. Correct. And when even number of inputs are 1, then output is high. Also, you can even number of input, then output. Now let's take the example for 3 input. 0 1 1. Let's say for example. So for 0 1 1, the output here will be, since we have the even number of ones, the output will be 1. And for 1 1 1, the output will be 0. Why? Because we have the odd number of ones here. Clear? Very much clear. Now let's see basic digital ICs. So these are basically the IC. See, you can see that this is IC 7400 NAND gate, basically a 14-pin ICs. Practically we are going to use this. So this is IC. So you can see that it is basically a 14-pin IC in which a single combination of IC we can have a 4 gate. So that's why this is called as a quad. Quad means 4 NAND gate. Inside an IC we have 4 NAND gates, and all NAND gates are of 2 input. All NAND gates are of 2 input. See, you can say this is 1 and 2 are the input pin, 3 is output, 4 and 5 are the input pin, 6 is output, 7 is the ground, 14 is the VCC for all ICs, and similarly for like other also. So we can have 4 NAND gate, 1, 2, 3 and 4 NAND gate. So that's why it is called quad NAND gate. Quad NAND gate. IC number is 7400. So this is 54 also, but they are earlier version. Nowadays we are using only 74 series. We are not using 54 series. And this is a NOR gate. This is a NOR gate, pin configuration of NOR. Again, it is a quad because in a single package we have 4 number of gates. That is 4 number of NOR gates. Again, this is a quad type of AND gate. See, by looking over the symbol only, you can answer the IC. Yes, because this is symbol for AND gate. You can differentiate now. See, this is AND gate symbol, this is NAND gate symbol, this is OR gate symbol, this is NOR gate symbol, this is XOR gate symbol, and this is NOT gate symbol. Generally we are not using XNOR gate because for functionally we are not using XNOR gate, but we are moreover using this 6 basic ICs. Yes, clear, very much clear. Yes, so thank you for listening. Thank you.